it is quite important because during the installation program and for the Python, because later on I my laptop cannot record, so you can record using your own device or software. So let me share my screen. So can you guys see my screen? See my slide? I have shared.
Can.
Okay, good. So here is the outline for today. So we will go to the installations of Pythons and some of the introductions of the basic package of Python, as well as the installations of this virtual environment for geospatial packages, and also lastly, case study for these predictions of concrete compressive strengths, and we will process this in Python. Okay, I think I will skip this a bit, and let me do some briefly introductions. So, why Python is important, and as uh, we are having uh, the geospatial class in this subject, or the geospatial element in this subject. So it we will also touch more later on about the introductions of Python or use Python for our geospatial analysis. So later on, here is some of the common remote sensing analysis in Python that you we will also demonstrate this in the later class. And now let's begin with the um, Python installations. And first, we need to access to the Anaconda website. Okay, I think I have showed this briefly to you last week. Okay, you may come down here and then click 64 bits graphical installer, and later on you just proceed with the normal installations. After you download the programs or the file here, you just proceed with the installations, and you need to tick both of these, since it will add automatically the path by Python path to your desktop based on the environmental variable. So okay, so after you have finished your installations, it will be like that. Okay, um, you will you will have this, and then and you will also have Jupyter Notebook here. Yeah, you will also have Jupyter Notebook here, but uh, if we want to if you want so once you have see this, we need to open our IDE. IDE is an environment for the user to do the coding. It is also the platform for the user to do or to carry out the coding in certain analysis. So here we will use Jupyter Notebook as one of the as the IDE in our class, and there are many IDE as a platform for you to do the coding. Some of the IDE are Spider, uh, PyCharm or Visual Studio. But uh, in our class, I prefer to use Jupyter Notebook. So let me open the IDE to you. And in order to open the IDE, I usually will click the Anaconda prompt first. And then if we see this, we can just key in uh, activate Jupyter book. Oh, we can just click Jupyter Notebook. We can just tap Jupyter Notebook, and and then uh, and then here is the environments for some of the file in the Jupyter Notebook, and then the format will be IPYNB. So this is the path in our user C, and then after that we can click either one of the environments, or this the basic one, and later on I will guide you how to install the virtual environments for the uh, geospatial work. So if you can add more here, and later on any of the geospatial work, you can use this rather than using the general one. Maybe the general one you can do some you can use them when you do some of the normal analysis. So this so as you can see here, here is the ID environments for Jupyter Notebook. So later on we will use this to carry out uh, our analysis or our coding. Or if you want to do any coding, you can do it here. Or we will use we will use this platform so in our coding. And next, uh, after you have opened the IDE, now how to how to install other virtual environments, or how to create other virtual environments in our Jupyter. So this an additional things. Of course, you can use the only one kernel or one Jupyter Notebook as you like. But for me, I'm sharing my experience when I do some of the geospatial work. So I basically have created my own virtual environment for this geospatial analysis. So to create the virtual environments, you can come back. Let me close this. So to create the virtual environment, you need to close the program first and open it again. Okay, so to create the virtual environment, I will share this slide to you. Just go to this Conda create name and 3.7, but I think my version is a bit uh, behind. Later on, when you download the download the new download the Pythons, I think they have been upgraded to 3.9 versions. So 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 by that, for this one, it's if you need to see which versions you uh, you have downloaded. So I think for the latest one is 3.9. So later on you just click enter. Since I have created, so I need to click. And after that, this command will create a new virtual environment. Will name the new virtual environments as geo underscore pi 37, and and then in this environment later on, after you have create, and then you can activate. Okay, so uh, activate this medium, and after you activate this medium, you can click. You can install the geospatial packages such as GDAL, Rasterios, and others. So I have provided the command here. So you can. So for this, you need to click install, and then follow by here others packages. Okay. and this may be not sufficient. This may be not sufficient since uh, we are dealing with the environment here. But how about if we want to create the kernel in our Jupyter notebook, as I showed just now? So once we have created uh, our virtual environment here, we need to link the virtual environment to the kernel in our Jupyter Notebook IDE, right? So because when we because after we have created the virtual environments, but it didn't link to our IDE yet. How to link? So it's quite simple. You can go it here, conda install Anaconda ID in this command, and this one, followed by this command, and you will the the new the new uh, kernel geo underscore pi 37 will be appear there appear there in the Jupyter Notebook IDE. So I have provided the reference here. I think it is not necessary because since but I recommend you it's better you create. I mean it's good you create another ID virtual environments uh, for just carry out a particular specific task, and then you can differentiate this task or this work. You can categorize them from the normal one that you work on. So let's go back. Let's go back to this notebook. But first, if we want to use any, since I have linked my kernel uh, with this geo pi 37 virtual environment, we need to type activate geo underscore pi 37 and then followed by Jupyter notebook. Okay, so let's go to the lesson today. Just a moment. Okay, as we can see, I have opened um, one of the file, Python file, into my Jupyter Notebook IDE. So as you can see here, and then I have used the Geo underscore Py 37 kernel as I have installed it earlier. So perhaps just a moment. I'm sorry. I hang on. Just a moment. Okay. So let me go. Or before we go to this, let me do some briefly introductions about the Python operations. So in basic Pythons, we will come across data types, loops, and functions. Okay, so here are the very simple uh, understanding about the data types in Python. So as it have 5 categories. First, it is numeric, and second, dictionary, boolean, set, or sequence type. So for numeric, any data types when uh, we process some of the data, it may be made up of integer. Integer is the whole number, and then complex number and float. Float is referred to decimal. So any value with the decimal is regarded as float in Python. And also for the sequence type, it has it made up of strings, list, and tuple. We will come across this later on. Okay, so we can see that if for string is a collection of one or more characters that put in a single quote, double quote, or triple quote. So in a so string is basically can be regarded also as a alphabet or a small sentence or characters. So uh, since if we in future when we want to when we use Python or we process some data will be in string format in Python. So for example, if we have categorical data like A, B, C, like the category A, category B, category C. So this one is regarded as the string. So we need to know this. And other than that, if we deal with some of the text in some of the text like they give the sentence. For example, I'm a hello world. So here, so it is also regarded as string. So you can just imagine that the string is made up of the either characters, alphabets, and a sentence. So this one of the type of data type in Python. And beside tuple are used to store multiple items in a single variables. So you can here I provided a simple example. And if you go further, if why is say in a single variables? Because in future, for example, if you want to include uh, some variables in mathematical equations and you want to process them using Python. So I'm trying to link this to the real scenario that can relate to our science and technologies discipline. So you can so at here we will have some of the single variables. For example, if you deal with the concrete strength, so we will have some materials like cement and so on. So these are the parameter or variables that will be considered. So um, so you might also use tuple to include them, uh, but it is more to the collections of the data. And a tuple is a collection which is in order and unchangeable. So it cannot be immutable since we see that the bracket here bracket here basically it will refer to and in the variable any variable inside here is in the order and then it cannot be changed unless but in an opposite way list can be changeable and then can be mutable, so it didn't go in order. So list is a like the in future you will deal with some of the uh, processing in the matrix form and so on. So it will in the array forms and other things. So list will work in this way. And beside that, dictionary is an unordered collections of data value and also data value used to store da- data value like a map, which unlike other data types that hold only single value as an element. And basically, in the dictionary, it hold key value pair. And we see in the previous element like the string and list, they didn't have they only have one element. But in the dictionary, the elements is referred to another elements. For example, it have the key and value pair. They come in a pair, and then in the at the centers, if it come with a pair, it will have double dot. So you can see double dot here. Okay, let's go to this before we go to the next one. So this, as we can see from here, when we want to run any program, we before that we need to understand what is file, some of the component in this Jupyter. So we have file. If I open this, and then we can save as save this file, and then if you want to download as, we can download as PDF and so on. So later when you do the assignment, maybe when doctor will give you some assignments, and then you may require to submit your code, so you can download as either in it's better to download in PDF, save them in PDF. But if you want to interact or you want to interact the code with your friend or share your code with your friend, and then later on your friend can at some point here or help you to do some in your work, or at some point in case you miss out something, and you can share this original code in a format of either IP1, IP and B. Later on, when you send this to your friend open it, and it will guide her or him to this, and then your friend will just continue to work out and give some comment and so on. And furthermore, .py is also an uh, important file in coding. Basically, we programmer will save the code in .py, and if you can access to some of the famous platform like GitHub, they will also save them in either .py or .ipynb. So you can download them and then change and then adopt their work and into your work, and you can use their code and apply it to your work, and then do some adjustment, and then it can be totally you I mean do some adjustment and creating the code and in the process of doing the coding. So this what the how to work or how to deal when come to do the coding. So beside now I would like to um, show you some of the things. Okay, so if I want to if I want to delete this if I want to delete this, I can just delete cell. And I think view later on you can see your own, and then later on insert is referred to if you want to insert a uh, new row. So you can just click insert cell below or above, and this one is to run the code when you want to run the code, or either just click it here, and of course run all is it will operate all. And okay, later here I will show it. And kernel, okay, kernel actually kernel is, if you remember, I told we use GeoPy37 to run our program, right? So this is GeoPy37 is a kernel that used to run the program. Okay, so when let's say when you run your program in a halfway, and maybe using the first CSV file, and then later on if you want to add, if you modify that CSV file, and then you found that um, I have modified the CSV Excel file by my own, and then I want to use this modified CSV file, right? But you have run them in a half, is already the halfway. So in this case, you need to stop the previous operation, right? Because you have because you want to use the latest modified file that to process you, and then you can just go to kernel and restart. That means it will restart all over again. And then because since sometimes when we run this code until here, let's say if I run this three row, and these three row may be interrelated. So if you bring it down, and then affect uh, it will affect your following analysis, since it is if you use the same variables or same file, right? So but if you want to restart the kernel, you can restart. If you want to reanalyze the program again. Okay, so other than that, let's say you can make some notes by go to Markdown. So you can see it didn't have the run icon here. So you can just do the note. For example, Python is you can just run it, and then it you can see it has the frame has been locked for this row, and then it can be your note and so on. And if you want to so markdown is basic introductions to Python. You can go to, for example, go to heading and click run. Basic uh, how to work in this Jupyter book. Okay, so and later on, actually, when you share this to your friend, in case your friend can give the answer, so your friend will use this. So it's the same to others like data analysis and analysts. They will share this means file, and then do some give some opinion by using this, right? So let's go to run our first program. So if you can see here, now we try to recognize the string, and then if you tap this variables, I'm a hello world. So print print the strings in a double quote. Actually, it will if you do the double apostrophe here, so it will run this. It will give this, and then if you want to you want to see string one is refer to which data types. So str is the short form for the string. So, so let's say if we go A here should be changed to A, and if you want to see any data type, okay, so the data type of A variable is string, right? Okay, so now we have executed one of the first programs. Let's go to the list. Okay, so for this list, we can see that in the list there's it is represented, or it is carried on in the form of index. For example, 0, 1, 2. So now if I want to extract these elements, I I need to print list, and then double bracket 0, and then it will extract this feature apple. If I as if I give one, if it will extract orange. If I want to extract the watermelon, 2, right? So later on, if I want to extract 3, it will give me error. List is index is out of the range. So basically, list will deal with some sort of the if you deal with the mathematics or any of the array, you will use this most often. If you want to, if you use the area to perform some of the image analysis, you will see this. Okay, tuple is quite straightforward because in the list, is represented in the form of index, but tuple you can just print them out if you want to extract them straight away. Uh, you can extract them straight away, or either you can also do the same to print the list, to key in the index, and then come out with this, provide use this with the elements. And dictionary is, as we come across, is in the key value pair. So basically it will have double dot, and then as the beginning, here is the key, and Honda is the value. Okay, so later on, pet is a key and dog is the value. So let's say if I want to check the value Honda here, so it come with a pair. I need to key in the model, so it gives me Honda. Okay, so let me give some of the example. Okay, if you come across the foot, if apple we have three apple. We have three apple, and then orange, four orange. So if I want to extract the number of apple, so if I want to extract the number of apple, it will give me the value. So here is the functions of the dictionary. And then let's go to the loops. The loops is, if you if later on, if you want to process any kind of the uh, repetitions or in our iterations, we can uh, we can we need to use loops. For example, count equal to 0. So it was, while count less than 3. So since we have assigned the variable 0 and then less than 3, so it later on it will when we print out the hello world by giving this count equal to count plus 1, so it will go from starting from this 0 and plus 1, 0, 1, 2, and so it will give 3. It will give 3 hello world. How about if we change it 3 to 4, so later on it will count from 0, 1, 2, 3, and then stop to 4, since it is the less than, is not less than or equal and or equal. So after that, let's go to the functions. So functions is quite important. It's also when you write a program, you use functions very often because your program may consist of many functions. For example, if you want to run the uh, basic statistics, mean or mediums, so later on you will create your own functions and then it will run it for you. And for uh, this here is the functions without variables, and then we can just print a click our function is hello from functions, and since we have provide the our functions here as the my functions, so if you want to print this one, you can just type my underscore functions bracket, and then it will give you the hello from a functions. and and if your functions have the arguments or the parameters, so later on um, you need to provide the parameters to in your to your functions, Sweden, India, and Brazil, and then later on it will print this, and with the country is referred to the parameters. Okay, so go to the next. Let's go to the next part after we have covered some of the basic Python. So I will introduce you about the introductions of basic packages of Python. So one is NumPy, Pandas, and Matplotlib. We will come across, I mean, here is the very basic package in Python. So NumPy is quite important because when we deal with some of the array, or when we deal with the some mathematic equations, operations, and so on. So we will be probably use these packages, this library most often. And apart from this, if we process the uh, image can be represented in a pixel. So in the pixels, if we want to program to read it in a pixel, it will it will it will represent it in a number. Each pixels of the image is a number. Some of them call digital number. So from so based on this, we need to use NumPy library to process our to read or to convert the the image into the numerical form that can be represent or that can be recognized by the program in a following analysis. And today we will not use the NumPy package. And Pandas is a Python package uh, that provide us to work to read and do some analysis when we use the structured data. Structured data. If we want to analyze the structured data, we will be probably uh, using pandas. And Matplotlib is a interesting library that enable us to do some of the data visualizations and also do some of the plotting and so on. Since now, basically, most of us here have used Microsoft Excel to do some plotting, such as line graph, pie chart, uh, bar graph, and what else, and many others. And but in Python, Matplotlib can we can use Matplotlib to do these visualizations, and there are many more in this library. Okay, let's see it. So if you want to plot the line graph, and I have run the code, so we can see with this command we can plot the line graph. And first we need to import the Matplotlib packages, and then NumPy, because I give some array from 0 to 6 in the x-axis and 0 to 40 to in the y-axis, and then show it and then plot it using this command, this code. Okay, so here is a very simple plot. It's very simple plot. If you want to if you want to do if you want to plot another line graph, first we need to import our Matplotlib pyplot plt. Then if we have variables x, and 20, 40, 60, and 80, y equal to we can do some simple plot. Okay, you can see uh, I have uh, I have plotted a new one, and with the uh, with given numbers for x-axis, with the range from 10 until 80 and y until 20 until 80. And if we want to give the if you want to give the name for x-axis and y-axis, we can go to we can provide this and provide the title to them for y-axis. So Let's go to the next one. After we have seen the line graph, how about the bar graph? We can also plot the bar graph here. Just- Okay. Okay, we can plot our bar graph here using matplotlib. Okay, so here is some of the example, and also we can also show plot a simple pie chart using matplotlib. So we can see the these packages, and later on you if you want to refer to this package, if you want to see the documentations of these packages, you can just straight away click matplotlib and compile. So here's some of the official documentations that can guide us to know about to know more about that particular library. For example, matplotlib, you can there are many of the references guide provided. So check out plot type. We can see there are many plot type here, histogram and so on, uh, and some of the examples how to plot. So you can refer it here. Okay, I think for now, do you have any questions before we go to the case study? Do you have any questions to ask? You may.
You Hao.
Yeah. Prof?
Yeah, maybe you can ask the students whether they managed to install the Python or not, and you can check whether they managed to follow the installation,
Okay.
and then maybe give them like 5 to 10 minutes break before continuing with the case study.
Okay.
Okay, all right. Thank you.
So uh, so how is the installations? Did you manage to install the Python in your desktop?
Right now, I'm installed. Currently, still waiting for the software to finish downloading. But so far, I can catch up with everything.
Okay, great, great, great. So how about others?
I couldn't install it, to be honest. I don't know why. Maybe I'm using MacBook, so maybe I will check out later after the class.
Okay, sure. Okay, I think I believe that some of you now has is installing and downloading the program. Perhaps we can take a brief break for 10 minutes. We will come back at 11:41. Yeah, let's go to the next part. Now I will demonstrate a basic analyzing using machine learning workflow in Python, and we will take one of the case study, which is the predictions of concrete compressive strengths given materials. So now we want to see the strength of the concrete compressive strength with the some of the parameters or some of the materials such as uh, cement, fly ash slag, water superplastic seizures, coarse aggregate, fine aggregate, ash, and uh, we want to see the effect of this all of these materials on the concrete compressive strength, and the concrete compressive strength is measured in the unit of CSMPA. So we will carry out these predictions in Pythons. Before we go to the code part, it's important for us to know the very general machine learning workflow that will be realized in our Python coding data. So first, it comprise of data input, exploratory data analysis, splitting the data, normalizations, building the models and evaluations. Here is the procedure of the overall general machine learning workflow. So of course, we need to have the data. So the data can be in the structural form. So we have our structure tabular data. Uh, we need to import our data into our Python. So it requires some of the library. So I have mentioned pandas can help to import the data into our library. Not only import, it also can help to read the data in our in into this IDE. And we also display some of the basic informations such as missing value, unknowns, and also to run some of the basic statistics such as mean, mediums, and minimum, maximums, and others. Also, it's important for us to carry out the EDA, exploratory data analysis, in the machine learning workflow to see the data distributions of each of the features. So later on, I will show in the code, in the coding part. So for example, pairwise is help us to visualize the relationship among the features we have. So the features here are the uh, the materials like the cement, water, fine aggregate, coarse aggregate, and others. And we will also use to plot the histogram for each of the features to see the data distributions among the features. So, um, so so that we can also plot the heat map and to see the correlations of uh, between the features with the our target, uh, our response variable, which is concrete compressive strength (CSMPA), and we can also plot the box plot. Okay, so after that, if we Boxplot can help to check the range of each features and also to see the outlier. I'm sure that you have come across if you take the calculus or a- any other subjects that related to the statistics in your undergraduate program. So you will come across this since it is part of the statistic. And in the following analysis, we will do the data splitting, which uh, we will split the data into the 70% for training to develop the model and 30% to do the validations or evaluations. Since if we have developed the model, we need to do some evaluations or assessment. So part of the data should be reserved for evaluations, and it will be followed by the feature scaling. There are many methods to do the features scaling. The purpose to do the feature scaling is to standardize our features. A very basic rule is to standardize the features to limited way, normally distributed form, and of course is to also normalize the data for each feature so that it can fit into the model. Because if we discover that some of the features uh, didn't follow the normal distributions or binomial distributions, then we straight away take the data and draw data without feature scaling and fit into the model. The accuracy that we get will be will be low, and then will not be accurate. And the most important one, because you want to do the predictions of this, for example, of this concrete compressive strength for the constructions, for example, in your civil engineering discipline. So it's, it, it is important to predict the value and give the and very accurate value, right? So if it give the wrong value, and it will be a serious matter because it didn't reflect whatever um, that in the ground. So that happened in the ground. So it's quite important. So after that, we will develop linear regressions. So we will use the linear regressions to develop the model, and we will do the evaluations. So there are some of the performance matrices that we will be used, such as R squared, mean square error, and root mean square error. And we will do some of the, and then lastly, we will plot the scatter plot to show the predicted and actual value, just to see the fitness of the model that we have developed. Okay, let's go to the coding part. Okay, first, the most important thing when we want to do any operations or analysis in our using Python, we need to import the necessary libraries that we want to use. So in this case, uh, we have see that pandas, matplotlib, and seaborn that can help uh, to uh, that can help in our analysis. So I didn't explain seaborn just now. You can also go to the official site of this seaborn. Okay. So actually, seaborn is to do some statistical analysis and then display in an interactive way. It means it not only help to carry out some of the statistical analysis, and then it will also visualize them in a very good design. So, for example, if you want to plot the bar plot and then with some of the coloring, so Seaborn will be a good choice. Okay, so now import the data. So I think after the class, I will provide you this data, and then along with the slide and also this code for you to, so that you can follow. Okay, so actually I'm using pandas to open the CSV file, since I import pandas as the short form PD. If we only import pandas, later on we need to type the full name of the pandas. So as PD is, you can but basically in a we usually say that the short form of this pandas is PD, and then the short form of the matplotlib is PLT, and NumPy is NP. Yeah. After we have read the file, CSV file, okay, you can display some, we can see some of the basic information, and also if we type .info none no means it didn't have any unknown data, unknown value, missing value in our data. And .describe is to perform very general basic statistics such as mean, standard deviations, minimum 25% of this of the overall 50%, 75%, and maximums. And if you want to further confirm that whether our data is having the missing data value or not, you can we need to use is no functions. Okay, so now let's go to the exploratory data analysis. So now we need to use Seaborn. So in order to plot the pairwise, we can, in the Seaborn, we need to tab the pair plot, so pair plot is referred to one of the functions from this Seaborn library, right? So let me run it. Just a moment, take some second. And let's go to the histogram. Okay, so histogram is how many bins you want, and X label and Y label. This is the size of X label and Y label. Okay, so let me explain it further. For this Seaborns, how to interpret. Since we visualize it, we need to interpret them. So we can see for this pairwise, for example, cement and the CSMPA. CSMPA is the concrete compressive strength. So concrete compressive strength CSMPA will be regarded as the target, and then we will use it to predict the value. So we can see the relationship between the features and the target, the cement. So we can see most of the cement is ranging from 100 100 to 500, whereas where against the strength is from here to less than 80. So we can interpret it in this way. And how to interpret this? Actually, this is the distributions of the data. How many data? How sparse? How the data distribute? Whether it's in the normally distributed form or it is distributed sparsely, and we can see. And later on, if it not follow the distributed way, normal distributed way or form, so we need to do some feature and engineering. Okay, so let's plot the scatter plot. So let's plot the scatter plot between the strength and also the cement, right? So what is the difference between the scatter plot and here? Because pairwise plot, pair plot has display all of the features in our data at once. And if you want to see them individually, so you can use scatter plot. So we can see more clearly here. So we can see the cement range from the 100 to more than 500, whereas strength is from the here to the less than until 80, and then we can see the lower the distributions of this strength. When the strength become low, how much is the cement and so on. So you can also do the same for other features. And now we can plot the correlations in the heat map to see the relationship between the variables. Okay, so we can see that cement give the higher correlations and positive correlations, whereas water give the negative correlations. Okay, so we can also plot the box plot for each of the features, so we can see out of this interquartile range is the outlier. So this blue dot is referred to the outlier. So let's go to the model developments. Before the model developments, we need to assign that what is x, what is y. Actually, y is basically referred to the target. S is referred to the features. So in this sense, we need to drop our strength, because strength is not features, but is in the target. So now next we need to do some data splitting. So we need to split our data into 70 training and 30 testing. So from here we need to use the scikit-learn. Okay, so scikit-learn and sklearn is the same. Let me introduce these packages to you. Scikit-learn. Okay. Scikit-learn is a library, machine learning library that can help to carry out any of the analysis related to the machine learnings, either classification, regressions, and many others. And also it can also consist of some of the feature selections, methods, pre-processing, feature engineering, and also the data splitting, and as well as the evaluation part. So we need to use scikit-learn. We need to use a function of scikit-learn to to help us in the whole machine learning workflow. So now we even though we want to perform the pre-processing, we also need to use this package. So in this package, we have the standard scalar functions. So, but there are others pre-processing techniques in the scikit-learn. You can see the recommendations later in their official website. So now we have do the data partitioning or data splitting, and then we also did the pre-processing. Okay, so we can see that when we run these functions, it is interrelated, is related to each other from the previous row to the next row, and then it will bring forward, and then is continuous. Okay, so now we want to use the linear regressions to build our model, to build our regression model. So we need to use also the scikit-learn to we need to use the scikit-learn library with their linear regressions functions. Okay, so now this row is to feed our data into the into the into the more linear regressions functions, and later on followed by, okay, once we have fit our training data, because remember that I have split the data into the 70% training and 30% testing, right? So this training data has been used to develop the linear regressions model, and later on 30% testing data will be used to the evaluations or the assessment. So now after that we want to evaluate our model. So we can see that the predicted score is R square equal to 0.594, and the others evaluations metrics such as the mean square error and root mean square error is about the 109 dot sevens and 10.47. Okay, and now let's see let's plot the scatter plot to see the fitness between the predicted values and actual values. So here is the fitness between the predicted and actual value. We can see the regression line, and since the model can still be improved, maybe using some of the pre-process technique. So, but anyway, we get the R square of 0.59. Then at least it has some of the uh, some fit to this model based on our existing data. Okay, so until this part, I think that's all from my part. Any questions?
Any question, students?
No questions.
Okay, so so far, what Mr. Yuhao has done is that he has introduced you to the Python programming language. The first time that you can and then the environment where you do the analysis using Python for our data. and also some examples of the relevant libraries. Okay, because in Python there are many libraries that can be used for our um, but we have to choose the relevant libraries that we use for us. Okay, so Mr. Yuha has already explained to you about some of the libraries. Um, there are general libraries like NumPy and Pandas, and also there are specific libraries for geospatial data like GeoPandas. These are the ones that we use for content reporter. Okay, and Mr. Yuha has already presented a very specific case study that is directly relevant to a case in Italy. Okay, so you can go and look at the code. So you can see them by default. Okay, so at the moment the correlation or the they call it performance of the model given by the example is 0.59. Okay, so I would like to ask you, is this a good indicator of the quality of the model or not? I want to ask the students, what is your opinion about the range of 0.59? Please comment on this 0.59 range. We have done a spread assessment before, right? So, 0.5 now. Any of the students have a question? Or I will pick up a note. Okay, Satya, please tell me what is your opinion about 0.59.
I'm sorry, doctor, but I think your microphone is quite muffly. I can hardly understand what you're trying
Can I
to.
hear me?
I can hear you, but it's quite unclear. I don't know if it's just my laptop or.
Okay, maybe problem with the device. Yuhao, can you hear me?
Yeah, I can you hear you, Prof. It's a little bit unclear. Well, I still can I still can hear you. What you are saying? Just a little bit unclear.
One
Yeah,
minute, 1 minute. Okay, wait.
just a little bit. Yeah.
Wait a minute. I can shift my device. Okay, can you hear me?
Now it's more clear. Yes, doctor.
Okay, can you hear me now?
Yeah.
Yes, doctor.
Very
Okay,
clear.
I have shifted my device. Okay, so all right. Okay, let me just recall on what we have done. Okay, so basically, Mr. Yu Hao today has introduced to us about Python programming language, as well as the environment that we can use, okay, to process our data using Python. There are lots of IDEs that can be used, but we choose a Jupyter Lab or Jupyter Notebook for our work. And we have seen several libraries. Okay, for example, NumPy, Pandas, GDAL, and so on. There are many libraries that we can use, okay, but we will choose only the relevant ones. And also a case study in the application of Python for machine learning model.
okay, has been presented by Yu Hao. So at the moment, this model is using a method called linear regression to predict the material strength, okay, based on the data that we have collected in the lab. Probably this kind of study for some of you are quite similar to what you are doing as well in maybe your courses or in your final year project. Okay, so at the moment we have the R squared value of 0.59 for the model. So my question is that I'm asking Satya just now, I don't know whether he's around. Satya, are you in? Anybody can confirm whether Satya is here?
I checked his name and his name is not present. I think he is absent today.
Okay. All right. Maybe Song.
Yes, doctor.
Yeah, Song. The value at the moment for the model is 0.59. What is your opinion about this value? Is it good enough for the model or not?
0.59 I think is not enough.
Mm-hmm. What will be your target to further improve? What will be the value that you maybe that you are trying to achieve probably to improve further?
Maybe near to 1.
Okay, very good. Okay, so you have demonstrated the understanding about regression. Okay, so we should go closer to 1, right? So meaning that the value for the model that we are using at the moment is not good enough, right? So there are a lot of other algorithms or models that we can try other than linear regression. As we go further in this course, we can explore more models. So you will be doing something like this. At least this is one of the examples for regression case. We also will go on later with classification case. And at least today, what is important is that I want to make sure that I just want to make sure that everyone is able to install Python in their computer. Okay, and from next week onwards, we can just straight away proceed with classification of images and so on. Okay, so this is just giving you an example, the practical example of an application of Python. Yeah, so any questions about what we have covered so far? Anything you would like to ask about Python in general, or the libraries, or maybe you are still not clear about modeling in Python? What kind of modeling you have done before in R? Have you done any machine learning in R before? As you said, you have done R for programming. So have you done any machine learning analysis in R? What you have done in R actually?
Doctor, as for our RStudio previously and our project, what we did was we finding the suitable sizes for the I-beam, like the analysis, something like that.
Size of what? Sorry.
Size of the I-beam, suitable size. whether it
I-beam.
fail or not, something like that.
I-beam. What do you mean by that?
The dimensions for the universal beam.
Oh, okay, okay. All right. But you haven't done any machine learning.
I don't think we have.
Okay, okay, fine. Okay, so as we go, as I mentioned to you, machine learning is very important for this class. So we will explore further the usage of machine learning algorithms for predicting values, okay, like regression, or predicting classes and categories, okay, which is classification. Okay, that's what we will do a lot in this course. Okay, but I hope that you managed to install Python on your computer. Okay. Anything else, Yuhao, that you like to inform the students?
Yes, Prof, I will distribute the data to the student later, and along with the slide and also uh, this Python file.
Okay. So this concrete data later on, Yuhao will share. Okay. This data is open data. You can use it freely. You can explore. I think this is quite an interesting data and directly relevant to what you are doing as well. So you can see that this is almost similar to the case study I presented last week, just a different application. Over here you have several features as well, several parameters. There are many other things that you can explore in this data, like the correlation between the variables, the multicollinearity, and so on, and linearity or non-linearity of the variables. Maybe the linear regression model is not suitable for this data because it cannot capture the non-linear behaviors of the variable properties, but we haven't really gone into that in details. Okay, so this is I mean, we can explore that further. Yeah. Okay, so anything else, in general, Farah, anything? I think Farah is quite, you are playing around with quite a lot of machine learning algorithms at the moment.
Yes, doctor. I just maybe like wondering, since I'm using McNemar's test for my FYP project, so can I do it using Python? Like,
Yes, yes,
oh,
absolutely. Anything that we can almost, I mean, basically do everything in the Python environment. We just need to find the code for that.
oh, okay.
Yeah, there are codes for McNemar test in Python as well. You have used McNemar test in using what?
Uh,
What you
so
have
for the previous for pixel-based classification, I'm uh,
How
there's
do you
someone currently Mr. Yihao is helping me with the McNemar's test.
Okay, right. Oh, okay, yeah,
Yeah.
right. Yeah, that can be done also in the Python environment. You can program it.
Oh, okay.
Okay. How about the others? You can also if you have images as well, we can read that in this Python IDE as well. So if you have like concrete images or whatever materials, yeah, images and so on, we can do the processing as well in the Python environment. So this is very powerful environment. Okay, that can help us with our work. You can also include later on. You will see how we read satellite images in Python as well. How we perform classification or extracting indices and so on from the satellite images in the same Python Jupyter environment. Okay, and also Python can be integrated with commercial software or non-commercial software, like if you have ArcGIS, if you have Envy, or you have QGIS, you can also integrate Python in that environment so that you can do editing and modifications, or you can create your own codes, okay, to process your data. So it's a very powerful environment to be used. Also later we are going to compare the use of Python with visual programming software like Orange or Nime. Okay, there is also an alternative for us if we don't want to deal so much with programming. There are also other options, but probably it is limited if you want to implement certain algorithms because you are going to be restricted a bit with whatever is available in the software. That one will be discussed later on. Okay, so Hao, next week we can, after we have done this, we can go into the geospatial part of Python, yeah?
Okay, Prof.
Okay, we can start with satellite images next week.
Okay.
Okay, and also we have the spectroscopy data as well.
Yeah.
Yeah. Okay, so any last question? So if you don't have any further questions, we can stop here for today. Okay. Hao, maybe you can help to check all the students whether they have managed to install Python in their computer.
Okay.
Later on. Okay, so that nobody is going to miss the analysis, because the test, or the test or test 1 or test 2 will also include Python.
Okay.
Yeah. Okay, so with that, we can stop here for today. All right. So thank you very much, everyone. The attendance next week or the week later on, I will give you the hard copy. Okay, so don't worry about the attendance, but I have done the screenshot of the names that are present today. Wait a minute.
Yeah, Doctor.
Yeah, you are.
I think I missed one part, the important part.
Which that?
How to install the library in the IDE. I think that's the most important also.
Oh, you mean the pip install thing?
Yeah.
Okay, so you can explain to them now, no problem.
Okay. Let me share my screen. But I have demonstrated to you about the installations of geospatial library, right? GDAL and so on, conda, that commands. So this the command to install the geospatial library. But how about NumPy and so on? Okay, so I recommend you to, for example, go to PyPy website. Okay, so let's say if I want to install NumPy. So NumPy, it has many versions, but you can just copy here and then pip install NumPy and open your Jupyter notebook. Okay, because we want to use matplotlib NumPy, right? It will, when we install the IDE, it is a blank. is a blank one. So we need to install this package by this library by our own. For example, pip install numpy, so that we can run the analysis. We can use the functions of the inside the particular library. For example, matplotlib, because later on you will use matplotlib and pandas. Just a moment. Later on you will use pandas, matplotlib, and Seaborn. You need to install by your own by going to PyPy and website. Click here and then you can see actually here is also have some of the documentations, and then it will also link you to the website that I have introduced, the original website. But most important one, we need to install the package first before we run any analysis related to that particular library. So before we import them, because if we didn't have the library, we cannot import, right? So you need to install and paste it here, but I have installed. So we can see requirement already satisfied because I have installed. So how to check our IDE have all kind of the required library that we want to deal with? You can go to tab this PIP list, if I'm mistaken. Okay, so you can see these are the library that I have installed and use it for the analysis. So once matplotlib have assist here, you can go ahead by using this library from any function to perform any analysis in from here. So pandas, yeah. So before that, you need to remember that you need to install so that you can perform the analysis, and also scikit-learn. Since later on you will deal with scikit-learn, right? Because sklearn is a short form for scikit-learn. So it's easy. You just take the name and copy. So just to ensure when you use the function of any of the library, you need to install first. If not, you cannot perform any analysis from this library. So yeah, I think that's all from me, Doctor.
Okay, thank you very much, Yu Hao. I think my advice is that the students will need to practice with a simple exercise like the concrete exercise. Okay, so they get familiar with basic operations in Python for machine learning. All right. Okay, guys, I think we will stop here for today. Okay, so thank you very much again to Yu Hao, okay, for the demonstration. Okay, and for the students for coming. Right. Okay, so I wish you a good Ramadan, and I'll see you next week. Okay.
Thank you, Doctor. Thank you, Hao.
All right. Thank you.
Doctor.
Okay. Assalamualaikum. Bye.